Well, hello, everybody. This is just a review for those who could use a little bit of extra practice on how to convert an improper fraction. Let's say you multiplied 3 times, we'll say 2/7. Actually, that won't work. Never mind. Well, let's clear that. There we go. Let's say you multiplied 4, there we go, times 2/7, and we'll follow the process. And numerator to numerator, we get 8/7. So it's an improper fraction. One of the best things you can do is just remember that an improper fraction means it is equal to more. That's important. More than 1. Okay? So that's all an improper fraction means. It's equal to more than 1. So if you have 8/7, it means you have more than one whole thing. Okay? Let's think a little bit about what this means. It means I have a whole, and my one whole was divided into 7 equal parts. So pretend here's my whole. I'm not going to divide it right now. And I have one whole, and it was divided into 7 equal parts. So if I used all of that, I would have used 7/7. But the thing is, for this, I need 8/7. So if we think about the story of chocolate bars, like, okay, so I ate 8/7 of a chocolate bar. So I go to the store and I buy one whole chocolate bar and I eat all of it. So I ate all 7/7. But 7/7 isn't the same thing as 8/7. So I walk back to the store and I buy another whole chocolate bar. But I've already eaten 7/7 of the chocolate bar and I need to just eat 8/7 of the chocolate bar. So on this one, on the second one I bought, I only need one little piece of it. I only need 1/7. And that makes sense because 7/7, if we think about adding fractions, 7/7 plus 1/7 equals 8/7. Okay. So that makes sense because I have 7/7 here and 1/7 here. This is a whole, right? I ate all of it. It was cut into 7 pieces. I ate all 7. So I ate one whole plus 1/7. Okay. I ate one whole plus 1/7. That makes sense. Let's go over here, and I can also show you on our fractions app here. So let's say you multiply, let's say 5 wholes times 2/3. So say you have to make 5 cakes, and each cake needs 2/3 of a cup of flour. How many 2/3 or how many thirds do I need? I'm going to multiply numerators. 5 times 2 is 10. And I'm going to multiply denominators. 1 times 3 is 3. So I need 10/3 cups of flour for my cake. Well, that means I could just scoop my one, if I had a 1/3 measuring cup, which I actually do, right? That just means I would need to scoop, here's my measuring cup, I would dump it into my cake 10 times, right? And that would give me 10/3 if I did that. But it would be a lot easier if I could just figure out how many whole cups I have and how many parts of a cup I have. So in order to do that, I could use fraction strips here to show you. Okay, so, well, what kind of fraction strips do I need? Well, I'm going to look here at the denominator. I need wholes that were cut into groups of 3. All right, that's cool. So let's do that. So we're going to grab a whole and we're cutting it into 3 parts. Cool. And remember, we need 10/3. So I'm going to color this whole. 1, 2, 3. You'll add my label. You'll see I have 3/3. 3/3 is not the same as 10/3. So I need to go grab another one with 3 parts. And let's see, I'm going to color all of those. So I have 3/3 plus 3/3, that's 6. 6 is not the same as 10/3, so I need to grab another one with 3 parts, and I need to color all 3 of those. There we go. And I can count, right? I can count these. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9/3, but I need 10/3. So I'm going back. I'm buying another chocolate bar, but I only need 10/3. So I'm only coloring one of those. If you look at this visually, you can see that I have 3 holes, and down at the bottom, I don't have a hole. I just have 1/3. So my conversion from 10/3 to a mixed number is I get 3 holes and 1/3. And I can count them again: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10/3 is the same as 3 holes and 1/3. Let's clear the screen. There we go. We're going to clear this as well. Oopsies. Helps if I have the mouse. Let's clear that. So a couple of different ways that you could do this. And I find most students are successful drawing it out. So let's say you had 12/5. When you start, oftentimes to draw it out is helpful. Now, because we're just making sketches to help us solve this problem, I don't think you need to partition them. Oftentimes I'll draw just a circle, and I'll be like, okay, I have 12/5. So one hole would have 5 of those fifths, but 5/5 is not the same as 12/5. So I have to go buy another hole or get another hole. And 5/5 plus another 5/5 is 10/5, but that's not the same as 12/5. So I'll sketch it for myself again. And I only need 2 of the fifths from this piece right here, from this last one. So these are my holes because they contain 5/5, and I have 2 of them. And then from the other one right here, I didn't use all of the pieces. I just had 2/5 of that piece. So that's one way to do it. I find this one does help kids too. You can visualize in your head. You can picture like, okay, well, if one hole had 5 pieces, 2 holes would have 10 pieces. So I would need 2 holes, and I need a third one, but only 2/5 of it, right? So I'm only using the 2 holes. That's how a lot of students have had success with this in the past. Another way you can do this is mathematically, and I'll just show you that one. But I think it's important that you understand like why you get your answer. Okay. So this is just sheer math right here using arithmetic. And we start here on the bottom and we ask ourselves, how many times can 5 go into 12 without going over? So this is where if you might need to say, okay, well, 5 times 1 is 5. 5 times 2 is 10. 5 times 3, and those I know look like S's. They're supposed to be 5s. 5 times 3 would be too much. So the closest I can get without going over is to multiply it by 2. So I do this. I say 5 times 2. Okay. So 5 times 2 is 10. I'm going to put the 10 here. 5 times 2 is 10. 12 minus 10 is 2. I just carried the denominator over. Fifths. So you'll see we got the same answer. I have 2 holes and 2/5. So, right? That would give me 2 holes and 2/5. That makes sense because 2 holes means I have 5/5. Think about adding fractions. Plus another 5/5. Remember, one hole would have all 5 pieces, and I have 2 of them, and 2/5. So we can use what we know about adding fractions with like denominators to help us. And 5 plus 5 is 10, plus 2 is 12. And remember, the fifths don't change. They're just fifths. And that's how I could double check my answer. So that's another way you can do it. I'll walk through that one more time because it's not as clear as if we do a drawing. Let's do, let's see, we have 9 quarters. So to do this in the drawing way, I'll do it both ways for us. So to do it with sketches, if I know that my whole has been divided into quarters and I need 9 of them, so here's my first thing, and it has all 4 quarters. So there's one whole, right? 4 quarters is the same as one whole, but 4 quarters is not the same as 9 quarters. So I need to go get another whole, 4 quarters in that one. So now I have 4 quarters plus another 4 quarters is 8 quarters, but I need 9 quarters. So I need to go get another one, but I'm only using 1 quarter of this one. Okay. So that's my 2 wholes and 1 quarter extra. Okay, 2 wholes plus 1 quarter extra. To do this, just with arithmetic, if I have 9 quarters, I'm going to say to myself, how many times can 4 go into 9? How many groups of 4 are in 9 without going over? Get as close as I can. I know 4 times 1 is 4. I know 4 times 2 is 8. Ooh, that's really close. I know 4 times 3 is 12. That's too much. So it will be 2. So 4 times 2 is 8. Okay, so 4 times 2 equals, I kind of always draw this arrow, equals 8. 9 minus 8 is 1. Denominator doesn't change. And I grab my wholes from over here. So I have 2 wholes plus 1 quarter. And so those are the 2 different ways you can do that. I hope this video review helps any of you who still are working your brain around converting improper fractions to mixed numbers. The best thing you can do is practice, and I'll post some extra practice on a Google Classroom for you. Okay, bye.